let's start for today. 1, 2, and 3. Hello, Anushri. Hello. Hello. Time to study. I should. Is this okay? I am fine, thank you. I'm fine. My day was good. My day was good. And for the correct sequence of steps in a habit course, such as money, slow, and so. cis-trans complementation test. Test cannot be used for the following statement is false for cis-trans complementation test. The test cannot be used for exhibiting intragenital complementation. Complementation associated with the specific I turn on the light? You got the distance. Follow you. Oh my god. ready. Americano. Should I study later? Made into the present in the same chromosome. Non is a true situation. Crossover percentage between any two genes can never exceed. The phenomenon of masking the expression of a gene by another non-allelic gene is known as masking the expression of a gene by another. Expression of one gene is modified mask inhibited separate. The phenotypic ratio of complementary factor is -7. In a dihybrid cross, F2 phenotypic ratio 15 is to 1 results due to option 1 epistatic genes, option 2 duplicate genes, option 3 inhibitory genes, option 4 complementary genes. Which is the right answer? Duplicate gene interaction, also called duplicate dominant. Phenotypic ratio 7 is to 1 is to 1 is to 7 in ratio versus incomplete dominance, interaction of genes, linkage phenomenon, codominance. The linkage phenomenon, genes are located close to each other on the same complement tend to be inherited through the line can result in a characteristic phenotype. Which phenomenon? Phenotypic ratio 7 is to 1 is to 1 is to 1 in F2 generation refers to option 1 incomplete dominance, option 2 interaction of genes, option 3 linkage phenomenon, option 4 codominance. Give me the right answer. 7 is to 1 is to 1 is 7.1. Interaction of genes is the right answer. Phenotypic ratio in the F2 generation indicates modified Mendelian ratio caused by gene interaction. In such cases, two or more genes interact to control a single trait producing a Mendelian ratio. Loss involvement. In a cross, same genotype in In a cross, the same genotypic and phenotypic F2 ratio as 1:2:1 represents the case of dihybrid cross. Monohybrid cross with incomplete dominance. Codominance. Monohybrid cross with complete dominance. So the answer is maybe incomplete dominance. genotypes on mating produce offspring of 45 blacks, 15 cream color, 45, 15, 15. Which of the following gene interaction may account for this result? Not completely recessive. Incomplete dominance. Dominant epistasis. Okay. Recessive epistasis हो सकता है. Incomplete dominance and penetrance. Incomplete dominance occurs when heterozygous genotype produces an intermediate phenotype between the two homozygous ones. Incomplete dominance, purple color in males, pink color for codominance is human skin color. Polygenes. One का 4, 2 का 3, 3 का 1. The phenomenon of two or more than two genes affecting the expression of each other is called I think two or more than two genes affecting the expression of each other. Crossing over. Handel described every character is influenced by the particular expression of gene, but when the characters are controlled by the combination of more than one gene, called gene interaction. A gene interaction in which one gene masks the effect of non-allelic gene is called epistasis. So now I'm gonna take a break for 5 minutes. करोगे? Let's see कि कितना. What are you studying? I'm studying biology. क्या था? विकास रुको रुको. Okay, let's read the comments now. How was your day? My day was not so good, not so bad. What are you studying? I was studying biology. Bhavya Joshi. Hi. Kindly King. What's up? What's up? Guys, anyone watch joking? Hello girl. Bro, anyone reply? Girl, hello you American bro. But she's obsessed with study. फिर कौन है? सूर्या परवीन. हाय. फिर कौन है? वजह ताली शमा. हाय. वजह ताली शमा का इतना ज़्यादा हाय है. Hi. Now I'm gonna take a break. So okay, bye. For 5 minutes. I think I should keep it. वैसे तो it's okay. Hi, Karan VY5R and hola amigo. Is anyone alive? Yes, I am alive. Still breathing. जिंदा लाश की तरह. Okay. Is it already 5 minutes? I don't think it's already 5 minutes. I took a 5-minute break, but I have nothing to do, so let me just continue. Okay. What you study? I am studying genetics right now. Genetics, yeah. Genetics. I am studying genetics. "5 minute of Pomodoro Wallo." No, I was doing Pomodoro for like 4 hours. Like I mean, I just took 5 minutes break. And it's not even 5 minutes, but I'm still gonna continue because I have nothing to do during my break, so yeah. Okay, let's start. You can join with me if you're studying. Um, Can you share what you learned so far? There are so many things that I learned. Which one should I explain? I don't know. Okay, epistasis is when a gene masks another gene. वही याद है. Inheritance is the phenomenon in which the offspring inherits all its plastid and mitochondrial genomes from the maternal parent. This is because the plastids and mitochondria are located on the cytoplasm of the egg cell, and sperm cell does not contribute any plastids or mitochondria. It's okay. जो याद है वही बता दो. So okay, I just studied वो maternal inheritance. तो maternal inheritance में ये होता है कि पापा का जीन से जाइगोट में ओनली मदर का क्लोरोप्ला नॉट क्लोरोप्लास्ट सो सॉरी मदर का वो पास होता है. मदर का माइटोकॉन्ड्रिया प्लास्टिड ये सब मदर का पास होता है, नॉट फादर का. Only this I can explain because I have no time. Yes, because the plastids and mitochondria are located, and it is because the plastids and mitochondria are located on the cytoplasm of the egg cell. Okay. Okay, plastids and mitochondria are located in the cytoplasm of the egg cell, and the sperm cell does not contribute any plastids or mitochondria to the zygote. Plastids and mitochondria only maternal inheritance में होता है. A boy whose parents and grandparents had normal vision is colorblind. What are the genotypes for this mother and his maternal grandmother respectively? Okay, boy whose parents and grandparents had normal vision is colorblind. Genotypes of his mother and his maternal grandmother. कैरियर होगा ना, कैरियर होगा तो थर्ड इज द आंसर. Okay. Cell itself is alive means life was already there and before the egg and sperm made. Yeah, I don't know, maybe. Cell was already not there. It was formed from small germs and evolution took place. And after that, more complex organisms were formed. So I don't think egg cells were like specifically present in a single like structure. I don't know. Maybe. In Lamnia peregrina, coiling behavior is called by a single gene. Textile coiling behavior is governed by the dominant allele, and sinistral coiling necrosis is made during sinistral as female and dextral as male. All the snails are sinistral and dextral in again F3 ratio of 3 dextral. Again in F3 a ratio of 3 dextral and 1 is the classic phenotype which exhibits maternal effects in coiling direction of snail shells includes dextra plus sinistral. All life progeny is dextral coils, implying that dextral is dominant over sinistral. However, in the F1 crows, all the F1 snails are also dextral. The reciprocal cause dextra the classic phenotype which exhibits maternal effect is coiling direction of snail shells. In the cross, dextral coils implying that dextral is dominant over sinistral. However, the F1 and the F1 cross, the reciprocal cross dextral and the sinistral produces F1 progeny that are all left. Direction of coiling in a pond snail species X exhibits maternal effect. Okay, assuming that the coiling is governed by a single locus with the two alleles, where dextral coiling is dominant over sinistral coiling. Okay, right-handed coiling is what will be the phenotype F2 generation if a homozygous sinistral female is crossed with a homozygous dextral male? If a homozygous sinistral female, तो अगर sinistral होगा तो all sinistral होगा. नहीं, all dextral. If a homozygous sinistral female is crossed with a homozygous dextral male, सब dextral हो जाएगा. Direction of shell quilling. Dextral जो right-handed होता है, sinistral left-handed. Controlled by mother's genotype, not offspring's genotype. अगर mother जो dominant होगा तो offspring's phenotype will be dextral right-handed. अगर mother is sinistral mother होने से चलो भी sinistral होगा, left-handed girl offspring. The orientation of first cell cleavage in embryo depends on the cytoplasmic factors from mother's side. The trait shows maternal effect, no cytoplasmic inheritance. So why is the answer? If a homozygous sinistral female is crossed by a homozygous dextral male, all will be sinistral. If a homozygous sinistral female is crossed with a homozygous dextral male, all the offsprings will be dextral. First option. Second option, all will be sinistral. Third option, both dextral and sinistral in 3:1 ratio. Fourth option, both sinistral and dextral in 3:1 ratio. So this question is in context with Snell coiling. So what is the answer? Give me the correct answer. All will be sinistral. I gave the right answer and this book has the wrong answer. Bullshit. Snell shows a maternal effect. Okay. Homozygous sinistral In the book, it's showing the offsprings will be all textile. Okay. So what if it's in the F2 generation? Like in context with F2 generation, will the phenotype of a mother affect the offspring's phenotype? Okay. Even the F2 generation and the phenotype of the mother still determines the offspring coiling direction. Okay, snail coiling. The gene of coiling are inherited normally Mendelian. The phenotype depends on the genotype of the heterozygous. Initial none. F1 generation में DD. All offspring phenotypes semestral because the mother has DD. Okay. क्या लिखा है? Only life can give birth to another life means just forms are changing or it is reaction of two chemicals met together and form something new. पता नहीं. I'm not an expert, so I don't know. What's running in your tab font? Tab front of you. It's a Pomodoro jar. It's just a Pomodoro. Gene can carry the emotion, physical health, and even intelligence from parents. Yeah, I guess. Genes carry everything: skin color, hair, height, everything. I don't know about emotional वाला. वो भी होगा लेकिन. Genes carry literally everything जो इंसान है. The cross which is performed to a certain cytoplasmic inheritance is the cross which is performed to a certain cytoplasmic inheritance is back cross, distant cross, reciprocal cross, and test cross. Okay, it is a cross that is performed to a certain cytoplasmic inheritance is reciprocal cross. In a reciprocal cross, same male and female parents are crossed in opposite directions. Same male and female parents are crossed in opposite direction. This allows the researcher to determine whether the observed phenotype is due to the genes of the parents or the cytoplasm of the parents. Okay. ये वाला क्रॉस में क्या करता है कि male and female are crossed in opposite direction. Researchers to determine whether female and male are same male and female parents are crossed in opposite directions. This allows the researcher to determine is due to the genes of the parents or the cytoplasm of the parents. Okay. two genes Z and Y are linked and are 30 map units apart. If two genes, okay, Z and Y are linked and 30 units apart, the cross between ZY, ZY and ZY, the fraction of progeny with genotype ZY, ZY will be in a cross between, okay, इसका आंसर will be big Z and big Y. Small z and small y, and the fraction of progeny with genotype ZY and ZY will be 25, 25, 25, 25, okay. In a diploid plant, the number of linkage groups, एक diploid plant में the number of linkage groups equal diploid number of chromosomes. The number of linkage groups equal haploid number of chromosomes. Total number of chromosomes in pollen mother cell. Number of chromatids present in diploid cell. Number of chromatids present. The correct answer is 1. Diploid number of chromosomes. A linkage group is a group of genes on a chromosome that tend to be inherited together because they are physically close to each other. In diploid organism, the number of linkage group is equal to the number of diploid chromosome. This is because the chromosome contains multiple genes that are linked to each other, and the number of chromosomes in a diploid cell is double the number of chromosomes in a haploid cell. Diploid plant, the number of linkage groups equal to diploid number of chromosomes. Haploid number, okay. Number of linkage such group equals to the diploid number of chromosomes. This is because each chromosome contains multiple genes, okay? Who coined the term linkage? T.H. Morgan, Bateson and Punnett, Correns, and Anton de Vries. The term linkage was coined by, I guess, T.H. Morgan, or I don't know. The term linkage was coined by, yes, T.H. Morgan. Can I vote the answer here? Father of plant tissue culture. T.H. Morgan. Complete linkage is found in male Drosophila, female hen, female cobra, Janka, and Silhawan. Complete linkage where two genes are located very close to each other on the same chromosome. It is typically observed in male Drosophila fruit flies. The sex chromosome X and Y are very small and exhibit limited genetic recombination, leading to the complete linkage in certain regions of these chromosomes. A scientist discovered a new trait in to localize the gene of autosomal or allosomal. He performed reciprocal cross. The reciprocal cross used which of the following? localize the gene to autosomal or allosomal. New trait, please. क्या बोल रहे हैं? Scientists discovered a new trait. Localize the gene to autosomal or allosomal. He performed reciprocal cross. The reciprocal cross yield which of the following? What the hell? The scientists performed reciprocal crosses, okay? To determine if a trait is autosomal or sex-linked. Autosomal है कि sex-linked है, allosomal है. The outcomes are autosomal A. Reciprocal crosses yield the same results, indicating the trait is not linked to sex chromosomes. Autosomal X-linked. Reciprocal crosses yield the same results, indicating the trait is not linked to sex chromosome. Okay. Reciprocal crosses yield different results. Daughter inherit the trait from affected fathers and son. While linked, only males show the trait and it is passed directly from father to son. Sex-linked generally refers to the X-linked trait. So the explanation of the same for X. When the autosomal genes are more readily expressed in one sex, it is known as. जब एक autosomal gene जो cytoplasmic inheritance, sex-linked inheritance. Four. 12 of 4. I think we could do it if we try. If only you say, Sophia, now that you and I. A couple has a female child with disease and 3 unaffected children. Neither of the parents affected with this disease. What will be the pattern? It will be autosomal recessive. 13. Autosomal recessive, autosomal recessive, please. Yes. A एक जनरेशन में होगा, एक जनरेशन में नहीं होगा, एक जनरेशन में होगा, एक जनरेशन में नहीं होगा. Mitochondrial DNA can be used to trace parental lineage because it is maternally transmitted, does not recombines at low rate. No, maternally transmitted, does not recombine. 14. Mitochondrial DNA is inherited exclusively from the mother and does not undergo recombination, making it useful tool for tracing maternal lineage. Extrachromosomal inheritance of male sterility was discovered in maize by extrachromosomal inheritance किसने दिया था bullshit. The one and Oliver Overman and Jones and Clark will be maybe Jones and Clark. Extrachromosomal inheritance. Payne et al. Extrachromosomal inheritance. Please. Extrachromosomal inheritance. M. Rhodes is credited with the inheritance of male sterility in maize. M. Rhodes. In plants, the maternal influence in extranuclear inheritance owes to copper particles, algastic substance, chloroplast, and centromere. Obviously, chloroplast. Chloroplast, which contain their own DNA and their typically inherited maternal in the plants. This means the trait associated with chloroplast DNA passed on from mother to extrachromosomal inheritance of male sterility was discovered in maize by M. Rhodes. Chloroplast cytoplasmic male sterility (CMS) is the result of dash in the mitochondrial genome. Cytoplasmic male sterility (CMS) is the result of dash in the mitochondrial genome. Sterility and the result of mutation in the mitochondrial result of cytoplasmic male sterility is the result of dash hybridization in the mitochondrial genome. Mutation in 17. Caused by the mutations in the mitochondrial genome which affect the normal functioning of mitochondria in male reproductive organs, leading to the inability to produce functional pollen. Cytoplasmic male sterility is typically caused by mutations in the mitochondrial genome which affect the normal functioning of the mitochondria in male reproductive organs, leading to the inability to produce functional pollens. Inheritance of characters in both male and female children. The source must inheritance of characters in both male and female children. The source must be X chromosome, Y chromosome, X chromosome. Which of the following is not a type of extranuclear inheritance? Sexual segregation, vegetative segregation, uniparental, biparental inheritance. Sexual segregation is not a type of extranuclear inheritance. Sexual segregation is not a type of extranuclear inheritance. Extranuclear inheritance refers to the transmission of genetic material outside the nucleus. Sexual segregation is not a type of extranuclear inheritance. Extranuclear inheritance refers to the transmission of genetic material outside the nucleus, such as mitochondrial chloroplast DNA. Vegetative segregation, uniparental inheritance, biparental and sexual segregation typically refers to the separation of sexes in reproductive structure process and does not burden extranuclear inheritance. Okay. Which of the following is not an example of extrachromosomal inheritance? Snail shell coiling. Yeast petite, Drosophila bar-I, Neurospora pop. Which of the following is not an example of extrachromosomal inheritance? Drosophila bar-I is taken from the parent. The bar-I phenotype is not an example of chromosomal mutation. It is a result of chromosomal mutation. The other option is yeast petite, Neurospora pocky, snail shell coiling, extrachromosomal inheritance, which involves genetic information outside the chromosome, typically not the mitochondrial chloroplast. Okay. 85. What the heck? Hey, what are you studying? No view. Mm, ओ मैं म्यूट में था हम बोल दिया
अच्छा हो ना शक्ति को पिचिंग वाला नहीं सुने शक्ति वाला देखने से तो
ना कमेंट क्या हो गया मैं वाईफाई वाईफाई बहुत गंदा चल रहा है. Let me check my own internet. Okay. देखो ना, लेकिन मेरा कमेंट जो ना कुछ हो गया, इधर नहीं आ रहा है. Oh my God, क्या हो रहा है? क्या हो रहा है? ओके अभी आ गया. सो स्टॉप एक्टिंग ब्रो बोल रहे हो. ओ प्लीज, हम एक्टिंग नहीं कर रहे. जिन कैरी रहना, हम उसका वो रिप्लाई कर रहे हैं ना. ओके लेट्स कंटिन्यू.
तेरी स्कूटर
स्टेंजिन चोस्पेल तो वही था ना, शक्ति था ना. शक्ति जैसा कि कमेंट किया ना मेरा राजस्थान वाला व्लॉग में. पहली बार बुल का बच्चा पहली बार देखा ऐसा बोला. लेकिन हम कब ऐसा बोला?
पीछे एक बुल है, ये बुल का बच्चा. अलग नहीं. अब कौन कौन की बोलता है? अलग अलग.
लेकिन हम बुल का बच्चा तो पहली बार ही देखा था.
सुनो मुझे कितना चक्कर है.
I've been living it up. Dorapsi. सोचो के
मम्मी कितना चक्कर है.
Let's start again. Pedigree analysis. Variations in chromosome number represented by 2n+1 in organisms are called trisomy. Trisomy refers to the presence of extra chromosome resulting in the copies of particular chromosome instead of usual two copies. The correct karyotype description of Patau syndrome is 47 plus 13. Patau syndrome. Patau syndrome, also known as trisomy 13, is a chromosomal disorder where individuals have 3 copies of chromosome number 13 instead of usual 2. Okay, this results in the total of 47 chromosomes. But also known as trisomy 13, okay? In a chromosomal disorder where the copies of chromosome number have 3 copies of chromosome number 13 अच्छा, पटाव सिंड्रोम में क्रोमोसोम नंबर 13 जो 3 होता है ट्राइसोमी। Plants having genetic constitution as 2n-2 are called monosomics, double monosomics, nolisomics, trisomics. Nullisomy is the loss of both pairs of homologous chromosomes. These individuals are called nullisomics as their chromosome composition is 2n-1. Common wheat Triticum aestivum is an important example of aneuploidy, allopolyploidy, autopolyploidy. Common wheat Triticum aestivum, I think allopolyploidy. It is an example of allopolyploid with 6 chromosome sets. For instance, a cross between tetraploid wheat Triticum AAA and Rizical BB would produce a hybrid progeny with a chromosomal composition of AAB. Allopoly with 6 chromosome sets. Rice has 6 chromosome sets. For instance, a cross between tetraploid with an organism with AAAA BB genotype is char AA allopolyploid. Monosomics in diploid for all its chromosome is known as monosomics in diploids for all its chromosome is known in all its chromosome is known for. The term monosomic is used to describe cell that has only a single copy of a given chromosome. Monosomic is used to describe a cell. Like as a cell to describe that it has only a single copy of a given chromosome. Monosomics in diploids for all its chromosome is known in Nicotiana tobacco. Monosomics in diploid for all its chromosome is known in Nicotiana tabacum. Okay. A trisomic plant shows a ring of 3 chromosomes in meiosis. Okay, I guess a trisomic plant that shows a ring of 3 chromosomes in meiosis. What type of trisomic will it be? Primary, secondary, tertiary, and compensatory. Chromosome in meiosis. A trisomic plant, if shows a ring of 3 chromosomes in meiosis, it is primary trisomy, one with the extra chromosome being normal. In addition to 2 similar chromosomes of a bivalent. It is primary trisomy. Primary trisomy. Primary trisomic is the one with extra chromosome being normal. Shows a ring of 3 chromosomes being normal. Triticum ST1 beet wheat. Triticum ST1 contains 2 different genomes, 2 similar genomes, 3 different genomes, 6 different genomes. 6.04. The beet wheat genome is classified as hexaploid genome. This means that it has 6 copies of each of its 7 chromosomes. The complete set numbering 42 chromosomes. Which of the following is most prevalent in natural plant population? Is most prevalent in natural plant population? Autopolyploidy is more common in plants. The triploid 3x, tetraploid 4x, and pentaploid 5x are autopolyploids because one basic genome is multiplied. Autopolyploids can be obtained after treatment with chemicals such as polycycline or ricillin, which affects spindle formation and induces chromosome disjunction during the mitosis. Okay, polycycline and oricillin. Any autopolyploidy is more common in plants. The triploid 3x, 4x, and 5x are autopolyploid because the basic genome is multiplied. Only the basic polyploids can be obtained after treatment with chemicals such as polycycline or oricillin, which infects spindle formation. Which of the following is correctly matched? Monosomic नहीं, wrong है. Nullisomic is trisomic 2n plus 3. Trisomic 2n plus 3, wrong. Double monosomic is the right answer. Double monosomic is missing 1 chromosome from each of 2 pair of homologous chromosome. 2n minus 1 minus 1, okay. Homologous chromosome से एक set pair is missing. That is called double monosomic. Double monosomic. Monosomic में 2n minus 1. Double monosomic में 2n minus 1 minus 1. Which of the following trisomy is characterized by the formation of a ring of 3 synaptic chromosomes? Ring of 3 synaptic chromosomes. Primary. Ring chromosomes are usually mosaic and effect chromosomes, so they're rarely found in mosaic trisomy. Are commonly mosaic for trisomy. Ring chromosome 20 syndrome is marked by characteristic seizure phenotype. Mosaic and effect chromosomes that are rarely found in mosaic trisomy. Three synaptic chromosome, ring 3 synaptic chromosome, three ring of 3 chromosome in meiosis जो प्राइमरी है, प्राइमरी ट्राइसोमी 5 का, लेकिन अगर 3 synaptic chromosomes होने से मेन का आंसर है ring chromosomes are usually mosaic in effect. Mosaic chromosomes are rarely found in mosaic trisomy. Commonly mosaic. Okay. Ring chromosome syndrome is marked by characteristic seizure phenotype. Which one of the following trisomy is characterized by the formation of a ring of 3 synaptic chromosomes? Option 1 primary, option 2 secondary, option 3 tertiary, option 4 quaternary. Which is the correct answer? This question is in context with pedigree analysis, human genetic disorders. Option 2 secondary trisomy. Okay. Extra chromosome is an identical copy of one of the homologous. Okay. Extra normal homologous. Primary trisomy जो extra normal homologous chromosome. Okay. Straight trivalent. Okay. Secondary trisomy is extra chromosome with identical arms, isoduplicate. Secondary trisomy तब होता है जब identical arms होता है. Okay. Extra normal. Tertiary trisomy, extra chromosome with derived from translocation. Quaternary trisomy, very rare, involves 4 homologous segments. Complex pairing involves 4 homologous segments. जब 4 homologous segments होते हैं ना secondary trisomy, extra chromosome with identical arms. और chromosome arrangement straight trivalent होता है. Ring of 3 synaptic chromosome involves part of a non-homologous chromosome. Complex pairing. Complex pairing. Monosomy, nullisomy, trisomy, tetrasomy. Okay. A का 4, B का 3, trisomy 2n+1. What? C का 1. Okay. D का 2. In the pedigree given below, a single dominant gene governs the trait. Pedigree given below, a single dominant gene governs the trait represented by full square and circle. What would be the probability of the trait appearing in the progeny of the cross between individuals of 3x2 and 3x3? 3x2 and 3x3. Okay. Happy be here, happy be here, happy be here. So this is autosomal dominant. Normal 50%. In Melisome, two chromosomes are missing. The chromosomal composition is probability of the trait appearing across between individuals because in a single dominant gene governs the trait filled with square and circle. What is the most likely mode of the following pedigree? It's skipping generations, so it is autosomal recessive. 12:1. Yes, okay. Yes, there is generations. Study the following pedigree. What could be the possible inheritance pattern? Yeah, baby. What can be the possible inheritance pattern? माँ से बेटा को लग रहा है नहीं माँ is also affected or autosomal resistance, autosomal inheritance. 13:4. Yes, autosomal inheritance, possible inheritance of the pedigree pattern because no generation skip occurs and affected progeny. What is the mode of inheritance in the pedigree given below? Okay. Yeah. Autosomal मेल से फीमेल को भी लग रहा है autosomal dominant. Yes. Patau syndrome is due to trisomy of chromosome number 13. 15 का है 1, yes. Klinefelter syndrome is a condition where the male has an extra X chromosome resulting in the karyotype XXY. This is a form of trisomy. Okay. Chromosome 18 in human results in chromosome number 18. Down syndrome, spontaneous abortion, Burkitt's Edwards syndrome. 17. Edwards syndrome. Chromosome. Hey, NEET student. I'm not a NEET student. Lowang mark. No, not a NEET student. क्रोमोसोम 13 का ट्राइसोमी को बोलता है पटाउ सिंड्रोम. Hello, anyone alive? Yes, I'm alive. Choco B7Z. Hi. अगर ट्राइसोमी इन क्रोमोसोम नंबर 18 ट्राइसोमी होने से एडवर्ड सिंड्रोम. Caused by autosomal dominant gene. Huntington disease, autosomal dominant gene. Okay. Autosomal dominant gene. Red-green color blindness is an example of genetic disorder. Red-green color blindness. It's an example of X-linked recessive. 19 का है. Yes. Okay. Turner syndrome is depicted by Turner syndrome is depicted by the presence of single X chromosome. Okay, let's read the comments. Up, where are you from? I'm from Arunachal Pradesh. What are you studying? I am studying genetics. Hello, anyone alive? Yes. Okay. Turner syndrome हो गया. Single X chromosome. copies of chromosome number 21. XXY. अगर एक मिसिंग होने से टर्नर सिंड्रोम. Okay. If it's X, only X, it is. And if it's extra XXY, XYY, Klinefelter syndrome. Chromosome trisomy is Patau syndrome, chromosome number 20. What time is it? It is 1:19 a.m. You are so pretty. Thank you. Thank you. So I'm gonna take a break for 5 minutes. Aku tabo. इतना क्या म्यूट करके रखा है पर भी ऐसे देख. Do you know N hyphen?
Yes, बोलो ना.
No.
Yes.
I know but I don't know कि हम नहीं देखते. मैं दोस्त को पता है. What you look like ALYSA. Elisa क्या है? Liu.
Elisa Liu वो
Thank you, हम नहीं जानते, नहीं जानते।
फेमस है, नहीं देखा। प्यारी है वो लेकिन, क्योंकि उसका बाल तेरे जैसा है ना, ऐसा उसका बाल हेलो है, हेलो।
सर्च करेगा ना,
ऐसे भी बहुत प्यारी है।
ALIS
हम उसका प्राइवेट अकाउंट में एडिट साली को दिखाओ,
ना,
असली का है।
तुम क्यों है?
क्योंकि वो पहले पब्लिक था, फिर वो कुछ दिनों में प्राइवेट करेगा बोल।
Is it your room? Yes, my room. ALYSA. Alyssa Liu.
या बहुत प्रिटी हो। ये आइस स्केटिंग इस साल आइस स्केटिंग में ये हुआ है ना।
Everybody's falling in love. कहाँ से
Figure
ये इतना
skating में?
सुंदर है, हम तो ऐसा ही नहीं।
ये मिक्स है ना, अमेरिकन और ये मिक्स। इसका प्राइवेट अकाउंट में
और उसका बाल इतना अच्छा से किया है।
इसका हेलो वाला बाल किया, बहुत प्यारी है, बहुत प्यारी है ये।
ये मेरा चीटिंग किया है बाल को।
ना झूठ है।
ओए देखो ना, मेरा बाल इसका जैसे बन रहा है इधर, अभी इधर जैसे।
इसलिए बोला यू लुक लाइक।
तो अभी हम बैंक्स को ऐसे ही रखेगा, ठीक है? हम इसको बहुत इनसिक्योर हो रहा था इसको देख के, ये कलर को देख के।
हाफ चाइनीज हाफ ऐसा कुछ होता होगा।
ओ मेरा बाल इसका जैसा हो रहा है, देखो ना, यहाँ से ब्लोंड करना पड़ेगा लेकिन।
चल हेलो कर देगा तेरा बाल को।
मेरे पापा तो हमको मार डालेगा उसके बाद, तो घर आने नहीं देगा।
बहुत टैलेंट है लेकिन इस काम में। यहाँ में छोड़ो ये वाला टैलेंट।
ये प्राइवेट क्यों कर दिया?
ये इसका असली अकाउंट है, और टैलेंट है ये जीत गया ना इस साल का आइस स्केटिंग में, फर्स्ट है इसलिए।
क्या दुनिया में?
हाँ दुनिया में। इसका स्पैम अकाउंट पहले पब्लिक था, तो कुछ दिनों में प्राइवेट जाएगा बोल रहा था, ऐसा गोइंग प्राइवेट लिखा है ना।
दिखाओ तो एक बार।
तो फिर कुछ दिनों में प्राइवेट जाएगा बोल के, तो हम जो जल्दी जल्दी फॉलो कर दिया, क्योंकि हमको इसका प्राइवेट अकाउंट देना है।
ये ना, थैंक यू। कुछ रुको, क्या बोल रहे हैं? पढ़ना कब स्टार्ट करोगे? रुको। कुछ भी मत बोलो, अभी मेरा ब्रेक है। ओ प्लीज, हम इतना पढ़ा है।
सही से
ऐसे पढ़ना कब स्टार्ट करोगे यार आप? Who is with you? This bitch is with me, my roommate. पढ़ना कब स्टार्ट करोगे यार आप? देखो ना, हम थोड़ा देर के लिए ब्रेक लिए, पर भी इन लोगों को इतना प्रॉब्लम हो रहा है। हेटर्स मजा किए।
17 आवर्स स्टडी विद मी शुरू।
ओ हम इसको पोस्ट करना भूल गया, अभी तो कम पढ़ना पड़ेगा। 4 hours। ओ सॉरी, पढ़ने का टाइम कंटिन्यू होते गया ब्रेक में भी, नहीं तो हम पोस्ट कर रहे थे पहले। Let's listen to a song together. थोड़ा हमको ये गाना बहुत पसंद है, तो let's listen to this song, Falling Behind.
तो बजाया जाए Falling Behind। रेडियो करके ऐसा करके करो ना।
स्वागत है आप सबको थ्रो ये रेडियो। Falling Behind। कॉपीराइट कर दो।
वो भी
नहीं, ऑलरेडी होगा। मैं तो हर वीडियो में, लेकिन आपको परवाह नहीं है। ब्राइटनेस कम कर देगा। मुझे ये पार्ट पसंद नहीं है, हमको बस ये वाला पार्ट पसंद है, मेन वाला। Everybody's falling in love and I'm falling behind. For years and years now I have it, and damn it, it's kind of weird. Okay, ज़्यादा टाइम वेस्ट नहीं करते हुए लेट्स कंटिन्यू। टाइम वेस्ट तो हो ही गया, हो ही गया। I'm so sorry if I missed. I'm gonna subscribe you. Thank you. क्या पढ़ रहे हो आप? I am studying genetics. Who is? अच्छा ये तो पढ़ लिया ना। OMG, you're so cute बोला। Thank you. Thank you. Thank you. हमको भी ऐसा ही लगता है बस। ऐसा बोल के पूरा haters लोग आ जाए। ऐसे बोल रहा था ना एक इंसान, जो हमको ऐसे बोल रहा था कि हम जब YouTube खोला था हमको तो बहुत हेट कमेंट्स मिल रहा था, आपको इतना प्यार क्यों मिल रहा है, और तो हम बोला क्या पता, ऐसा बोल रहा था। तो वो जो बोला कि ऐसा बोल रहा था कि शायद आप बिकॉज यू आर सो क्यूट इसलिए होता होगा शायद। हाँ हो सकते हैं। Let's start a new unit. हम ये लाइव में डायरेक्ट 3 यूनिट्स कंप्लीट किए, सो clap for me. Pedigree analysis is so good. Oh my god. पूरा बायोलॉजी ही पेडिग्री एनालिसिस का होने से कितना अच्छा होना था। 6 तुम नहीं पढ़ेगा ना मतलब?
हम कल
189 polygenic inheritance. 189. हमने बैंक्स को और काटेगा क्योंकि बहुत लंबा हो रहा है, फिर हमको लग रहा है कि ब्लैक और ब्लॉन्ड जो इक्वल हो जाएगा। Given below are 2 statements. One is labeled as assertion and the other is labeled as penetrance and expressivity are terms which can be used interchangeably. No, wrong. Expressivity is the degree to which a genotype is expressed as a phenotype within an individual, while penetrance refers to the percentage of individuals with a particular genotype who express the associated phenotype. Percentage of individuals. Yes. A is not correct. Yes, but R is correct. That's right. Which of the following does not hold true for quantitative traits? Which of the following doesn't hold true for quantitative traits? Quantitative traits are governed by several genes. Genes governing the trait do not follow Mendelian laws. Are influenced by the environment. If polygenic, several genotypes may produce the same phenotype. अगर polygenic होगा तो several genotypes may produce the same phenotype. I don't know what the answer is. A quantitative trait is measurable. Quantitative trait is a measurable phenotype that depends on the cumulative actions of many genes and the environment. Do not follow Mendelian laws, but several genotypes produce the same phenotype is known as syntropy. जब बहुत ज़्यादा genotypes produce the same phenotype, it's known as syntropy. Search for genotype. If polygenic, several genotypes may produce the same phenotype. but several genotypes produce the same phenotype is known as syntropy. F2 individuals obtained in a polygenic cross showed a total of 9 phenotypes, 1 by 256 individuals expressing either of the parent phenotypes. How many genes are expected to control such a trait? So we have 9 phenotypes and 1 by 7 and 9. Pairs of genes. The polygenic inheritance trait is controlled by 2 pairs of genes. So for 9 phenotype, 4 genes will be involved. 1, 2, 3, 4. F2 individuals obtained in a polygenic cross showed a total of 9 phenotypes and 1 by 256 individuals expressing either of the parental phenotypes. How many are expected to control such a trait? Which of the following statement is not true? Okay, 3. Quantitative traits are polygenic in nature. There can be multiple alleles of a locus, but there can be multiple alleles. Individual can have a maximum of 2 alleles. The 2 sister chromatids have different allelic configuration. Genetic maps are generally collinear with physical maps. Genetic maps are generally collinear with sister chromatids of same genera but can. There is the answer. The 2 sister chromatids can have different allelic configurations. Wrong. Okay, the ancestor chromatids carry the same genes in the same loci but can have different alleles, it is correct. It is because one half of the same. It is because of one half from the same. The correct answer is option C, because sister chromatids are duplicated copies of each other, so they will possess the same alleles of the same gene at the same locus. The number of phenotypes of gamete produced by plant having phenotype A, A, B, B, C, C, D, D. The number of type of gamete produced by plant having genotype A, A, B, B, C, C, D, D. The number of types of gamete produced by plant having phenotype 1, 2, 'A', 'B', 'C', 'D', 1, 2, 3, 4, 5 organs are here. Number of types of gametes and n is number of heterozygotes. N is equal to 1. The formula to calculate number of types of gametes 2n. N is the number of heterozygotes. हेटेरोजाइगस कितना है? एक है. The answer is 2. Gametes देखने के लिए number of heterozygous देखना चाहिए. तब तो होगा. The phenomenon in which an allele of one gene suppresses the activity of an allele of another gene is known as epistasis. Which of the following genomic combination refers to segmental alloploidy? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 3. An alloploid is an individual having more than complete, having 2 or more than complete sets of. So the correct answer is 3. The cross of F2 hybrid with either of dominant or recessive parent is known as. The cross of F2 hybrid with either its dominant or recessive parent is known as. Either its dominant or recessive parent. expression of characters in eukaryotic organism is mostly eukaryotic organism is monogenic, polygenic, multipolygenic, polygenic. A polygenic trait is a characteristic such as height, skin color that is influenced from mostly eukaryotic organism. What is polygenic traits? Traits controlled by a single gene. No. Traits not controlled by any. Traits controlled by 2 genes. Traits controlled by 3 or more genes. 4. Which of the following is a classic example of polygenic inheritance? Skin color in humans. We can see that this trait is not so distinct in non-human. What are polygenes? Genes involved in quantitative inheritance. Genes involved in qualitative inheritance. Genes involved in multiple genes for a single trait. 11 ka 4. What the hell? Polygenes. Genes which are involved in quantitative inheritance are called polygenes. Okay. Genes involved in quantitative inheritance are called polygenes. What was the ratio of F2 generation when red and white kernel variety of wheat were crossed? White and red kernel variety of wheat were crossed. Twelve ka 4:6:4:1. 1:4:6:4:1. Ratio of generation when red white kernel wheat varieties were crossed obtained 6 8 to the 16 17 18. 5 different phenotypic classes were obtained. 5 different phenotypic classes were obtained. Which of the following factors the amount melanin produced depends? On which of the following factors the amount of melanin produced depends? Number of recessive alleles, number of chromosomes present in an individual, number of dominant genes, number of loci present in DNA, number of recessive alleles, number of chromosomes present in an individual, number of dominant genes. 13. The 3 pairs of genes which determine the skin color in humans are present at 3 different loci, and each dominant allele of the gene is responsible for the amount of melanin. The 3 pairs of genes which determine are present at 3 different loci, and each dominant allele of the gene is responsible. And each dominant allele of the gene is responsible for the amount of melanin present in the skin. I think the answer is number of loci present in DNA. On which of the following factors the amount of melanin produced depends? Option 1, number of recessive alleles. 2, number of chromosomes present in an individual. 3, number of dominant genes. 4, number of loci present in DNA. Which is the correct answer? Number of dominant genes, okay. Each dominant allele of that gene is responsible for the amount of melanin present. The following conclusion can be made by studying a histogram. Extreme phenotypes are common. Intermediate phenotypes are more frequent. Conclusion can be made studying a histogram. Extreme phenotypes are common. Intermediate phenotypes are more frequent. Intermediate phenotypes are rare. All phenotypes are present in equal amounts. We can draw two conclusions by studying histogram that in a polygenic inheritance, the extreme phenotypes are rare. Extreme phenotypes are rare, okay, and the intermediate ones are more frequent. The extreme phenotypes are rare and the intermediate ones are more frequent. 15. Which of the following is an example of quantitative trait? 15 का है crop length in maize, height in humans, human intelligence, blood groups in humans, height of humans maybe. The crop length in maize, height in humans, human intelligence, milk and meat production. It's not an example of quantitative trait, okay? Human blood group. Crop length in maize, height in humans, human intelligence, milk and meat production, height in humans, and size, shape, and number of seeds and fruits are some of the common examples of quantitative traits. Which of the following is not an example of quantitative trait? 1. Cob length in maize. 2. Height in humans. 3. Human intelligence. 4. Blood groups in humans. Blood group in humans is not a quantitative trait, I guess. Cob length जो है option for blood group in humans, okay? They are controlled by many genes and show continuous variation, range of phenotypes, cob length in maize, height in humans, human intelligence, range. Okay. Whenever you can. Cause I'm break once again.
लेकिन ये समर में पता नहीं समर में कुछ अलग से प्यारा दिख रहा था। और उसका बात हो गया ना।
Do you use Instagram?
No.
I don't use Instagram. I am away from this social world. Instagram. I deactivated my Instagram 2 months ago. But my Instagram name is given in my YouTube bio. I'll reactivate my Instagram on March. So yeah, if you want to follow me, then you can at that time. Or you also look like Hana Bang. Who is Hana Bang? Let me search. सबका बाल ही बस ऐसा लग रहा है. ओह, इसका भी बाल ऐसा ऐसा था. अच्छा, ओके. Okay, study well. Bye. Bye bye. Okay. Break is over. Let's continue now. Page number 192, linkage. दो jeans Z and Y are linked and are 30 meg. Fraction of potential times 50%. LOD score is a measure of the interference of one chromosomal with another number of genes in an organism. The probability of linkage between two groups by the number of chromosomes in a cell. Score is a measure of the probability of linkage between two loci. LOD जो क्या है? Probability of linkage between two loci. Logarithm of odds. Score is a statistical estimate to calculate likelihood of two genes being located closer together on a chromosome. being linked. It is used in genetic linkage and based on the probability of a certain the genes are unlinked. This indicates that the two genes are likely to be linked, while low indicates that they are likely to be unlinked. In a diploid plant, the number of linkage groups equal to a diploid plant में the number of linkage groups equal to diploid number of chromosomes. A linkage group is a group of genes on a chromosome that tend to be inherited together. A linkage group is a group of genes on a chromosome. Each chromosome contains multiple genes that may be linked to each other. The number of chromosomes indicated. Who coined the term linkage? T.H. Morgan. Complete linkage is found in male Drosophila. Coupling and repulsion are two aspects of a single phenomenon called. Coupling or repulsion are two aspects of a single phenomenon called. Term linkage was 6. Repulsion are two aspects of single phenomenon called linkage. The concept of linkage merely which refers to the tendency of DNA sequences that are forced together on a chromosome. Coupling and repulsion are two aspects of this phenomenon. Coupling refers to linked genes being on the same chromosome, while repulsion linked genes being on different chromosomes. Okay. Coupling जो है linked genes on same chromosome. Repulsion is different chromosomes. Which of the following do not encompass reverse genetics? Genome editing, creating gene knockout mice, introducing mutations deterministically in a non-gene, novel gene discovery by genetic screen. Do not encompass reverse. Novel gene discovery by genetic screen. Reverse genetics is a method that is used to understand the function of a gene by analyzing the phenotypic effects of specific engineered gene sequences. The function of a gene by analyzing the phenotypic effects of specific engineered gene sequences. This involves processes like genome editing, creating gene neocortinoids. Novel gene discovery by genetic screens, on the other hand, is a forward genetic approach the smallest unit of genetic material which, upon mutation, produce a phenotypic effect is the सबसे छोटा unit of genetic material which, upon mutation, produce a phenotypic effect is gene mutant regulator inducer repair. Smallest unit of genetic material which upon mutation produce a phenotypic effect. Okay, muton. In the context of molecular genetics, mutant is the smallest unit of DNA with a gene that when mutated can lead to change in the amino acid sequence of the protein product, thus potentially producing a noticeable context of molecular genetics. Now, muton जो एक smallest unit of DNA है, इसके पास एक gene होता है जिसको म्यूट करने से lead to change in the amino acid का sequence of the protein product में change ला सकता है जो noticeable phenotype. Muton is the smallest genetic material upon mutation produces a phenotypic effect is mutant. Who coined the term linkage? Morgan. What term is used to describe the situation when two alleles do not assort independently? Do not separate independently. Linkage, obviously. Then linkage refers to tendency of alleles across together in a chromosome and to be inherited together. What is the process of introducing a mutation into a gene to study its effect is called genome sequencing, linkage mapping, reverse genetic, forward genetics. Reverse genetics जब एक म्यूटेशन को एक जीन में लाता है to study its effects, तो it is called reverse genetics. Reverse genetics. Which term refers to the location of a gene on a chromosome? Locus. There are 4 pairs of chromosomes in Drosophila. The linkage groups are present in it are 4 pairs of chromosomes है in Drosophila. The linkage group present in it are one more than the pair of chromosomes, one less than the pair of chromosomes. Pairs of chromosomes है. Eight group present are 13 का आंसर linkage groups are equal to haploid set of chromosome. Linkage is a group refers to the group of genes on a chromosome that tend when added together. Each pair represents a separate linkage group, therefore the correct answer is 4. If the percentage of crossing over between two genes is 10, then the distance between two genes is 40 map units, 10 centimorgans. Crossing over between two. The distance between two genes on a chromosome is measured in centimorgans or map units. It's a measure of the frequency of recombination between them. 1% crossing over is equal to 1 centimorgan map distance. If the percentage of crossing over between two genes is 10, then the distance between them is 10 centimorgans. 10 centimorgans or map units. If gene frequency between gene A and C is 2%, okay, B and C is equal to 13 and D 17%. The sequence of genes in a chromosome is A, D, B, C. A, D, B, C, 19, 4, 13, 2. The gene frequency between gene A and C is 2. A, C, B, D. What does a linkage map demonstrate? The physical structure of chromosomes, the relative positions of gene of chromosomes, the exact location, the exact locations of gene, and the sequence of nucleotides in a gene, the physical structure of chromosome. In a linkage map, the map unit MU is a centimorgan represent as 1% chance of recombination occurring between two genes, 10% chance of recombination occurring between one map unit. to the following statement is true about genes that are closer together on a chromosome. It have higher recombination frequency. False. They are less likely to be separated during crossing over. True. They have 50% chance of recombination. False. Their order cannot be determined on a linkage map. False. Yeah. Closer together, less likely to be separated during crossing over. What is the role of crossing over in the creation of a linkage map? Role of crossing over in the creation of a linkage map. It determines the physical structure of the chromosome. Mechanism to measure the relative distance between two genes. What is the role of map? Oh my god. That you also tell. It allows sequencing of the DNA and it prevents recombination from occurring. Crossing over in the creation of a 1942. It provides mechanism to measure the relative distance between genes crossing over recombination. If two genes have a recombination frequency of 50%, what does it say about the location of the chromosome? What does this suggest about their They are very close to each other. They are on different chromosomes. Their relative position cannot be determined. They are very close. They are at opposite ends of the same chromosome. Second, 20 different they are on different recombination frequency. The genes either on different chromosomes for above on the same chromosome as if they were on separate chromosome. Different chromosome may only say 50%. अच्छा ठीक है. Cause baby I'm afraid to fall. Linkage is done. Okay, let's see the comments. Janil Wankar, hi. Janil Wankar, फिर hi. DSP Shivam, hey there, good morning sis, good morning. Zaki Khan, Q4Q, hi. जागरी क्या लिखा दिखाई नहीं दे रहा. जागृति नाथ, hello. Oi. Oh, you are Northeastern. I'm from Assam, 10th grader. Hello. Yes, I'm Northeastern. थक गया. So I'm gonna take a break for 5 minutes. क्या लिखा है?
What the hell? You know.
I am having a break. क्या मेरा ब्रेक लेने से सबको क्या प्रॉब्लम है? हे द पुटिन, हे ये पढ़ाई हो रही है? नहीं, ये पढ़ाई नहीं हो रही, ये ब्रेक हो रही है, ब्रेक. आया थक गया, थोड़ा घूम के आएगा. Which class? I'm in college. Fembro, Fenbra. Fenbra ने बोला है what are you studying for? I am studying for ऐसे ही. I am studying ऐसे ही. 10th or 12th. I'm on college. I'm in college 3rd year. जल्दी जल्दी कुछ बोलना है तो बोलो. I'm gonna continue my studies again. So ये कुत्ता लोग क्या भौंक रहे हैं? मटर गश्ती खुली सड़क पे. ना 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 ऐसे ही. विच कोर्स? ऐसे ही मतलब ऐसे ही. बॉटनी कोर्स. डॉग्स हो, इतना ज़्यादा डॉग्स भौंक रहे. ये लोग लड़ रहे. टेरिटोरियल फाइट. Do you wanna see कि बाहर क्या हाल है? I don't know, लेकिन रुको. हाँ रुको, I'll try. दिख रहा है? These are stray dogs. Oh my god. And look at the moon. These dogs are really irritating. Oh my god. Oh क्या? Oh my god. They are not fighting for Parle-G. I'll explain. What they are fighting for. Actually, some of the dogs live inside, like park के अंदर रहता है कोई. फिर कुछ डॉग्स पार्क के बाहर रहता है. फिर बाहर वाला डॉग्स जो पार्क के अंदर आने का कोशिश कर रहा है, इसलिए अंदर वाला डॉग्स जो गुस्सा कर रहा है उसको. Yeah, that's the reason. And comment में क्या है? Your pets or stray dogs? They are stray dogs, not my pets. Oh my god. कौन सी स्ट्रीम ली थी आपने 11 में? कॉमर्स? नो, आई टुक साइंस, पीसीबी. और लोल. क्या लोल? क्या हुआ? What was your percentage in class 12? क्लास 12 में मेरा परसेंटेज था 75. बहुत कम था, इतना ही, 75 समथिंग. एंड दे वर नॉट फाइटिंग फॉर पार्ले जी. मैंने तो बता दिया ना वो तो. और क्या देखो, अभी अभी शांत हो गया, थोड़ा शांत हो गया. यू फ्रॉम? आई एम फ्रॉम अरुणाचल प्रदेश. मी कॉमर्स. ओ, कॉमर्स इज रियली टफ आई गेस. कॉमर्स में तो बहुत ज़्यादा फॉर्मूलास याद करना पड़ता है, मेरा तो माथा दर्द देता है. हमारे यहाँ शुरू हो गया क्या? डॉग्स. कुत्ता कुत्ता भौंकना शुरू हो गया क्या? दिस इज माई स्टडी टेबल. लेट मी शो यू माई स्टडी टेबल. These are my syllabus. This is my water bottle जो मैंने बनाया है खुद. नेल पॉलिश आर्ट. अबे ये कॉमर्स ठीक है पुटिन. तुम लोग बात करो. And wait, let me show you. Okay, this is the pen stand that I made. I live in PG, so yeah. Oh, so sorry. This is the pen stand that I made. ये देखो, ये मेरा फेवरेट एक्टर तिमोथी शालामेट. एंड दिस इज माई तिमोथी का बचपन का फोटो. और ये भी तिमोथी है. फिर इसको वापस रख देगा, ऐसा कुछ है. These are my flowers. This is the one that I made from ribbon. और हो गया, इसको वापस ऐसे रख देते हैं. This is my goofy. ये क्या बातें चल रहा है? हमारे यहाँ शुरू हो गया. इजी है कॉमर्स. 11 12 तो इजी है. आई डोंट थिंक कॉमर्स इज़ इजी. बस जो लोग बहुत टैलेंटेड होते हैं ना, उन लोगों के लिए शायद इजी होता है. उसके बाद डू यू लिव विद योर पेरेंट्स और हॉस्टल? बस বা মই SST কাৰণে প্ৰিপাৰেশ্যন কৰি আছোঁ. আপুনি অকণমান টিপ্स দিয়কচোন. ओ, इतना अच्छा आसामीज बोले हम. सुनो. हाँ, বা মই SST কাৰণে প্ৰিপাৰেশ্যন কৰি আছোঁ. আপুনি অকণমান টিप्स দিয়কচোন. अच्छा, तुम पुतिन और जागरीनाथ नहीं, जागृतिनाथ दोनों आसामीस हो क्या? नॉट ओनली बिजनेस, बहुत ऑप्शंस है. अच्छा, समवन इज बिहाइंड यू. वेयर? मत डराओ ना, क्या बोल रहे हैं? CA CMA CFA ACCA, ये क्या है? माथा दर्द हो रहा है ये देख के. Did I am Didi, I am Assamese living in Ghaziabad. GZB गाजियाबाद है क्या? शायद, if I'm not wrong. I'm from Delhi. Oh, इसीलिए तुम्हारा वहाँ पे कुत्ता भौंकना शुरू हो गया था ना। हम्म, ये GZB इस गाजियाबाद। अच्छा, थक गया पर पड़ गया, क्या करूँ। मेरे रूम का डेकोरेशन दिखाएगा टाइम पास। ओके, लेट्स कंटिन्यू। आप डेली लाइव आती हो? यस, लाइक आई ट्राई। नॉट डेली, हम 2-3 दिन से थोड़ा लगातार आने का कोशिश कर रहे हैं बस, क्योंकि हम अकेला पढ़ने से हमको बहुत नींद आते तो इसलिए। मटर गस्ती। Okay, now I'm gonna continue. Oh my god. Transformation, conjugation. खुली सड़क पे मैंने तो कभी बुक से नहीं पढ़ा। आप सोती कब हो? जब नींद आता है तब। There is no fixed timing. होली का छुट्टी चल रहा है, सो नो कॉलेज टुमारो। चैट जीपीटी है यस। पुतिन मोदी से क्या लिखा है? पुतिन मोदी से खो थोड़ा शी कर ले यार, सब बेकार लगता है। क्या बोल रहा है?
plasmid, one is episome. Now, what do you mean by plasmid and episome? What is the difference between the two? Now, if the DNA is present in cytoplasm, not in nucleus, if the DNA is present in cytoplasm, it is known as plasmid. It is not a chromosome. And if the DNA is present in nucleus, it is integrated with the chromosome but not a chromosome. So it is known as episome. Here you can see both, right? Can you see this plasmid here? It is present in the cytoplasm. It is present in the cytoplasm. It is DNA. It is genetic material. It is DNA in nature, but it is not a chromosome. That's why known as plasmid. And if this plasmid goes here and integrates with the chromosome, it is not a chromosome. It is integrating with the chromosome. So it is present in the nucleus. So the same plasmid will be known as episome. Can you count the pattern on this one? If you got the difference between the plasmid and the episome. Now a beautiful diagram in front of you to explain this concept. Listen, everyone listen here. Can you see here? This is a green color bacterial cell. Can you all see this is a bacterial cell? In the bacterial cell, please concentrate the DNA, the chromosome of the bacteria, the red color I'm marking right now. This is the bacterial DNA, or you can say bacterial chromosome to be simplified. Right? Now in this diagram, can you all see what are these circular structures? These circular structures. These circular structures are present outside the nucleus. They are present in cytoplasm. Basically, they are DNA in nature, but they are in cytoplasm. That's why known as plasmid. Yes, they are plasmid. Right? Now are present outside the cell. Can you? And if the DNA is present in nucleus, it is integrated with the chromosome, but not.
Extra chromosomal genetic.
Right? So one is plasmid, one is episome. Now what do you mean by plasmid and episome? What is the difference between the two? Now, if the DNA is present in cytoplasm, not in nucleus, if the DNA is present in cytoplasm, it is known as plasmid. It is not a chromosome. And if the DNA is present in nucleus, it is integrated with the chromosome but not a chromosome. So it is known as episome. Here you can see both, right? Can you see this plasmid here? It is present in the cytoplasm. It is present in the cytoplasm. It is DNA. It is genetic material. It is DNA in nature, but it is not a chromosome. That's why it is known as plasmid. And if this plasmid goes here and integrates with the chromosome, it is not a chromosome. It is integrating with the chromosome. So it is present in the nucleus. So the same plasmid will be known as episome. You can count the pattern on this point if you got the difference between the plasmid and the episome. Now a beautiful diagram in front of you to explain this concept. Listen, everyone listen here. Can you see here? This is the green color bacterial cell. Can you all see? This is the bacterial cell. In the bacterial cell, please concentrate the DNA, chromosome of the bacteria, the red color I'm marking right now. This is the bacterial DNA, or you can say bacterial chromosome to be simplified. Right? Now in this diagram, can you all see what are these circular structures? These circular structures. These circular structures are present outside the nucleus. They are present in cytoplasm. Basically, they are DNA in nature, but they are in cytoplasm. That's why known as plasmid. Yes, they are plasmid. Right? Now then the bacterial cell, the parent cell, is dividing into two daughter cells. You know, bacterial replication taking place from one parent cell, two daughters are formed. So the DNA divides. We know. Can you see the DNA is dividing? The chromosome is dividing, but the extra chromosomal DNA is also dividing. That is, I mean to say, plasmids replicate. Like chromosome only, plasmids replicate in the same. Plasmids are replicable in the same way as nucleus is replicating. You got my point? In both the daughter cells, the same number, exactly same plasmids are there as compared to parent cell. So they are doubling. They are replicating. We got it from this diagram. Now in the second diagram below, see the below diagram, the lower half. You can see here this is a plasmid. It is going in the nucleus and integrating. Now in this cell here, please everyone concentrate here. Here you can see the red one is the chromosome, but the blue one is not chromosome. It is DNA. It is a plasmid. It is integrated in the nucleus. Now it is not known as plasmid. Now it is known as episome. Now it is known as episome, and episome is also replicating in the same way as plasmid. So what we have learned, the summary is that there are two types of extra chromosomal genetic material. It is known as plasmid and episome. When it is present in cytoplasm, it is plasmid. When it is present in nucleus, integrated with the chromosome, it is known as episome. And plasmid and episome both are replicable in the same way as bacterial chromosome too. You can answer on this point on the summary. Everyone. So have you got it? Can you proceed ahead? You got it. So what we have learned plasmid and episome both replicate independently in the same way as the bacterial chromosome is doing. Right? So that is the way. Now let's come on gene transfer. This is the bacterial cell. Let me draw a bacteria in front of you. This is the bacterial cell A. This is the circular DNA. This is the circular DNA chromosome of the bacteria. Right? This is another bacteria. Let me draw another bacteria. This is bacteria number 2, and this is the DNA of this bacteria. Is it possible? I'm asking you. Is it possible to transfer the genes of this bacteria to this, of this bacteria to this bacteria? The transfer of genes I'm asking. The transfer of the genetic material. The transfer of the genes. The transfer of the DNA. What are the ways one bacteria can transfer the genes to other bacteria? What are the ways? So they are having 4 ways. Yes, of course it's possible. Shut up. Absolutely right. It's possible. So there are 4 ways by which we can do it. Of course. What are the 4 ways by which bacterial material, the genetic material, you can transfer from one bacteria to another? So the 4 ways are transformation, transjunction, lysogenic conversion, and conjugation. So this is today's topic. You have to understand the difference between the pros and importance, the pros and cons of each factor. Right? So these are the various methods by which the bacteria can transfer genes from one bacteria to another. Right? Now let me discuss these one by one in detail in the and we will solve an answer based on that. Right? So let me start with the first factor, transformation. Transformation. The word transformation you have to learn is the naked game. What do you mean by the term naked?
Once bacteriophage invokes another bacterium, host DNA is transferred and the recipient. Oh my god. Page assembly, okay. Page replication and the bacterial promoter. Okay, okay. some strands of example of conjugation. Transferable multi-drug resistance. all of the following are important mechanisms of bacteria except lateral gene transfer, conjugation gene transfer, vertical gene transfer. Mm. Vertical gene transfer. Drug resistance. Drug resistance transfer by bacteria phage. And transformation, transcription, transduction, transduction. Genetic transformation transferred by phage is called genetic information transferred by phage is called viral DNA is integrated into bacterial DNA in viral DNA is integrated into bacterial DNA in mechanism of direct transfer of free DNA. सोचो के मिलने comments. क्या बोल रहे हैं? कोको मेलन अंश देखिए क्या एक 3:29 4 6 7 3:30 5 hours 30 minutes. Okay. इश्क दे गलियां च खोया 6 7 8 3 5 4 5 6 7 3 4 5 6 7 8 8 hours 30 seconds. Okay. हो गया हो गया 284. How many hours is 289 90 290 minutes. How many hours is 290 minutes? Ew. Ew, ew, ew. Bye bye. Ta-ta-ra-ra, ta-ra-ra-ra-ra-ra-ra.